So we're going to talk about the preparation of simple ethers. And there's actually more than one way to make an ether. And we're going to focus on just kind of one strategy known as like acid catalyzed alcohol condensation, blah, blah, blah. But just one way that we make some of our simple ethers. This strategy, you might have heard that word there, does depend on that word condensation reaction, which is really a new type of reaction from some of the others that we've explored. Such as addition, substitution, elimination. So in a condensation reaction, whoops, come on, pen. We take two smaller molecules, and they don't have to be like that small or anything, but two smaller molecules are going to join together or bond together, join into a larger one. And often it does involve the loss of something, like for example, like a water molecule. So it can also be a dehydration reaction where we're condensing it through the removal of a water. But we start with two and we end with kind of one larger one and maybe the loss of a smaller molecule. So dehydration reactions are often a subcategory of condensation reactions. And so in preparing an ether, so maybe we should review our general structure of an ether. So let's get that up here. We have an oxygen that is single bonded to a carbon group, an alkyl or an aromatic on either side. So we have this, ether, you get it or you don't type of picture. So let's look then at how we could form an ether through the condensation of two alcohols. So I'm going to start with, here's going to be my alcohol. So you can see this is ethanol. It's a two-carbon group, two-carbon alkyl group, so ethyl, with a hydroxyl group on the carbon. And I am going to react it with another alcohol. Sometimes rather than drawing the two, we might just put a 2 in front of one of them. I kind of like to do this because it helps me visualize a little bit more what's happening. So this is acid catalyzed and does require some heat, which might look kind of similar to some reactions we've had with alcohols before. The heat, there's different heats that you want to get to for whether a condensation or a dehydration reaction will occur. I don't want you to worry about that, but just know different heats matter on what kind of products you're going to get, or you might end up getting a mix of products that then later you have to separate, usually using the fact that they're going to have different boiling points to separate them out. So maybe you can start to see how this could condense into this. So it would be through the loss of a water. So a water could be made through the loss, and we're not going to get into the mechanisms of how it happens. So if you're interested, there's some good YouTube videos I've watched today on just a reminder of that mechanism. So we lose a hydroxyl group of one and the hydrogen of the other. So see how we're kind of building into the possibility of this structure. So we do condense through the loss of an oxygen, of a water molecule, sorry. So then here now I'm gonna, this oxygen group is still there, and that's gonna be this oxygen right there. So let's kind of consider moving this one over to make our ether. So there's our oxygen, and of course, this hydrogen, let's expand that and kind of think about it in terms of it. So in leaving, it's left this single electron there, and oxygen doesn't have a full valence shell, and we've kind of done the same thing here where this carbon, our previously carbonyl carbon, has lost that electron it was sharing that was oxygen's, and so it too has an unfilled valence shell. So if those two single bond together, we refill their valence shell. And then we have that general structure of an ether, and it kind of looks to me like a little bunny. So let's give him bunny ears. Because it's, it's the ether bunny. It wait all year to get to tell that joke. So there we have our ether, and we could do this with other alcohols where we take two alcohols and we condense them into an overall larger structure, joining into a larger molecule through the removal of that water molecule. Now, this is a method that is used more often for symmetrical ethers. That means they have the exact same, that this is an example. They have, an ethyl on either side of the oxygen. We don't get into the chemistry of making unsymmetrical ethers, but if you are interested in that, I'm sure you can find some resources on it. So let me know if you have questions.